Part 1 installed PyTorch. Part 2 trained your first neural network. Now, it's time to teach your AI to see. In this guide, you'll build a convolutional neural network that classifies 10 kinds of real color photos. Every command is verified. Let's get started. Here's what we'll build. A classifier for 10 color photo classes using the CIFAR-10 dataset. 50,000 training images and 10,000 test images. Each one is 32 by 32 pixels in full color. Airplanes, cars, birds, cats, dogs, frogs, and more.
The images are tiny, but they're real photos. Let's teach our network to tell them apart.
Before we write code, let's check your setup. Open a terminal and type Python -- version. It should print Python 3.14.7 or any version from 3.10 up. Now check PyTorch. Type Python -c, import torch, print torch __ version. It prints 2.13.0. Your environment is ready.
Next, open your editor and create a new file called CIFAR-10 tutorial.py. Import torch, tortibgen, and the v2 transforms. The transform converts each photo to a float tensor and normalizes the colors.
Then load CIFAR-10 with Torxperio and wrap it in a data loader with batch size 4. Note the warning. On Windows or Mac OS, set numworkers to 0 if you hit a broken pipe error.
When you run the script for the first time, Tortibgen downloads the dataset. You'll see a progress bar, about 163 megabytes. Download it once and it's cached forever. The server can be slow, so don't worry if the bar crawls.
There's a fix at the end of this video. After the download, the data folder contains 5 training batches, a test batch, and the class names.
Now let's look at the data. We grab a random batch and display 4 images: a cat, a ship, a plane, and a frog. Each image is a 3 by 32 by 32 tensor with colors normalized to the range -1 to 1.
The PIM showed function unnormalizes them, so they look natural again.
Time to build a convolutional neural network. The first convolutional layer applies 6 filters to the color image, shrinking it from 32 to 28 pixels. Then a 2 by 2 pooling layer halves it again. A second convolution brings it to 16 channels. After pooling, the data flattens into 400 numbers, then flows through 120, then 84, then 10 output neurons. 1 per class. In total, about 62,000 parameters. 10 times smaller than part 2.
Training needs 2 more pieces. First, a loss function. Cross-entropy loss compares the model's 10 scores with the true label. A small loss means a good guess. Second, an optimizer. Stochastic gradient descent with a learning rate of 0.001 and momentum of 0.9.
Then the loop begins. Predict, measure loss, backpropagate, and update.
Repeat for every batch.
Now we train. Watch the loss go down batch after batch. It starts near 2.3, which is random guessing for 10 classes. After 2 epochs, it's down to 2.24. In total, 25,000 steps.
On a normal computer, that takes a while, maybe 10 to 30 minutes on CPU. Grab a coffee. Your network is learning to see.
Let's test the final model on 10,000 unseen images. It gets 54% right. That's 5 times better than random chance. Some classes are easier than others. Trucks reach over 70%. Birds are the hardest at about 34%. Not bad for a first convolutional network.
Finally, save your model. One line writes the weights to CIFARnet.pt, about 1/4 megabyte. To use it, load the file back with weights only and feed in a single image.
The network outputs 10 confidence scores, and the highest one wins. Our test image is a ship at almost 52% confidence. And the true label is also a ship, correct?
Want it faster? On a GPU, move your network and your data to the device. But don't expect a massive speedup, because your network is really small. Now the fixes. Download crawling, download the file manually, and set download to false. Broken pipe error? Set num workers to 0.
Matplotlib missing? Install it with pip. Accelerator error? Upgrade to Torch 2.13. Your first CNN is trained. Like, subscribe, and comment. Happy building!